What we have to find out is find the remainder when 7 power 103 is divided by 5. So honestly, it is little difficult to imagine that our binomial theorem can help us solving this problem. Okay, so 7 power 103 is to be divided by 5, and then we need to find out the remainder when 7 power 103 is divided by 5. Any guess?
The remainder actually, as you increase the power of 7, it will go in a particular pattern, no, sir. First remainder is 2, then remainder is 4, then remainder is 3, then remainder again 1, then again 2. So
right,
go on like that.
Is it going to repeat?
Yes, sir. Just we need the first digit, no, sir.
That's what I'm saying. That's what I'm saying. I understood what you said. That 7 leaves remainder 2, 7 square leaves remainder 4, 7 cube leaves remainder how much?
3.
3. 7 power 4 leaves remainder
1.
Now the point is that is it going to follow the pattern like this? Right. Now we have got 2, 4, 3, 9. Another digits like 5, 6, 0, anything like that are going to come or not, or is this pattern continued? What is 7 power 5? How much it will leave?
7, sir, because the last digit, since it's 1 into 7, first digit. First digit, since it's 1 into 7, it will be always 7.
Remainder. Question is remainder.
0. Sorry, yeah.
2.
Sorry.
You are dividing with 5.
Yeah, 2.
So what about 7 power 7?
4 again.
Right. So this pattern is continuing. So in this list, 7 power 103 leaves remainder 3, right? Because 7 power 4 leaves remainder 1. That means 7 power 4 power 25 also leave remainder 1 into 7 power 3 is 7 power 103. Right?
Yes, sir.
Now that we have come to know that 7 power 103 leaves remainder 3 when divided by 5, now let's see how binomial theorem can be used.
7 power 6 will give remainder 4. So 7 power 7 will give remainder 3.
I have to just get the confirmation. What happens to 7 power 7? Does it give remainder 4 for 3? No, sir. When it is divided by 3, it will give like that. When it is divided by 10, it leaves remainder 3. It is 8, 2, 3, 5, 4, 3. Even then also it should leave remainder 3 only. Is it following the pattern? That's what I asked you actually also.
Yes.
You have to make sure that this pattern is followed.
Yes, sir. It will follow the pattern.
So in that case,
7 power 6.
7 power 7 must not leave remainder 4 then if it follows pattern.
Yes, sir. The 7 power 6 that will leave remainder 4.
Oh, 7 power 6 is there. 7 power 6 leaves 4 and yes, 7 power 7 leaves remainder 3. Fine. So anyhow, this part is anyhow correct. So again we are going to ask the same question to ourselves, that how we are going to use binomial theorem. We have not used binomial theorem here. We have not used binomial theorem, right? So we need to use binomial theorem is what we put a condition on to ourselves, that how we can use binomial theorem. Okay. So what we will do is that let's use this or x plus 1 whole power n, any one of them. So if I use x plus 1 whole power n, x power n plus nc1 x to the power n minus 1, nc2 x to the power n minus 2, etc. up to nc n minus 1 into x plus 1. So we will try to put 7 power 103 into that form so that this x is a multiple of 5. Then we will see what remains here at the end of it. So what is the best thing that we can do is that 7 power 103 can be written as 7 into 7 power 102, 7 into 7 square power 51, because 7 square is going to give me a multiple of, closer multiple of 5, where a number that is close to. Now in this expansion, what's going to happen? When you compare x plus 1
Yes,
or
sir.
x minus 1 whole to the power of n, every term contains x, right? So, in this expansion 2, 7 into 50 minus 1 whole to the power of 51 is 7 into 50 power 51 minus 51c1 into 50 power 50, like this. What is going to be at the end? 51c50 into 50
Yes,
power
sir.
1 minus 1. So according to this, 7 into a multiple of 5, because each number is divisible by 5 except this last term. So I still can write this as 7 into a multiple of 5 minus 10 plus 3. So again this will become a multiple of 5 and then plus 3. So a multiple of 5 plus 3, that is, it leaves remainder 3. This is how we have used
Yes, sir.
binomial theorem to establish this fact. Now show that 25 power 170 minus 20 power 170 minus 8 power 170 plus 3 power 170 is divisible by 85. This we may not be using a binomial theorem, but of course these kind of questions also will come. There are things that you have to remember here is a power n minus b power n is divisible by a minus b. And see how you can use this to establish that it is divisible by 85.
Sir, then 25 power 170 minus 20 power 170 is divisible by 5. So is then even 8 power 170 minus 8 power 170 plus 3 power 170 is also another combination. Then if you take 25 and 8 and 20 and minus 20 and 3, and then we'll get, and their difference is again 17.
So it is divisible by 17 as well as it is divisible by 5. Hence this is divisible by 85, right? Now do this problem. Find the sum and find the coefficient of 1 plus x whole to the power 500 plus x into 1 plus x whole to the power 499 plus x square into 1 plus x whole to the power 498 plus x cube into 1 plus x 490 power 497, etc. up to x to the power 500. Can you guess how many terms are there in this?
501.
501 terms are there, right? And in how many terms you may see x power 301? In 1 plus x whole power 500 you will see 301. In 1 plus x whole to the power of 499 into x you will find. So in the first term it is 500c301 is where you will get, when I write 1 plus x whole to the power of n, each term, that is sigma ncr into x to the power r, right? So x power r coefficient is ncr. So in the first it is 500c301. In the second 499c300 because x is getting multiplied each term. In the next 498c299, 497c298. Like this it will continue. Last one will be 1 because x to the power 301 into 1 plus x whatever, 1 plus x whole to the power whatever that remains. So there you are going to get 1. So this is basically the coefficient of x to the power 301. But does it have a value? Are we able to, will we be able to find out a single expression or a simple expression for the whole of this coefficient or not? Can you guess a pattern or can you make out a pattern there? Or at least I give you a clue that this is a GP. This is a GP. Can you make out what is that? What is that GP? And if it is a GP, what is the common ratio? What is the first term? And thereby what should be its sum? This is the GP. First term 1 plus x whole to the power 500. Common ratio x divided by 1 plus x. Each time x is getting multiplied and divided by 1 plus x. Hello? Hello?
Yes, sir.
X divided by 1 plus x is the common ratio and total number of terms 501. So you know how to write the sum of the GP. What is that sum? Can you tell me? How do you write this sum? I will give you a clue. A square plus AB plus B square. This is also in GP.
And B by
By A is the b by a is the common ratio. So how do I write this? Because the first term is a square into 1 minus r cube divided by 1 minus r. So that is a cube into a cube minus b cube divided by a cube by a minus b. So that's what you will get, a cube minus b cube divided by a minus b. So what is your guess? What is your take on this? This is the clue. What do you think is the sum? It is 1 plus x whole to the power 501 minus x to the power 501 divided by 1 plus x minus 1 minus x. So it is simply 1 plus x whole to the power 501 minus x to the power 501. A power n minus b power n. A power n minus b power n is a minus b into, Venkatesh just now asked, a power n minus 1 plus a power n minus 2 into b plus a power n minus 3 into b square plus a power n minus 4 into b cube, etc. b power n minus 1. So it's 1 plus x whole to the power 501 minus x to the power 501. So coefficient of x to the power of 301, the answer for this is 501c 301. That is the answer. So all this is going to be equal to, the value of that is going to be equal to this. There may be a question that what is the value of that? Also could be a question. So you have to identify that these are coefficients in some form of expression, and this is the coefficient of the same power in some other form of the expression, and then you need to develop the equality and then make out, yes, both are same. Now, I give a simpler problem for you because you have to work it out. Find the sum of the coefficients of the polynomial resulted in this expansion. Find the sum of the coefficients. Babu, how do you find the coefficient, sum of the coefficient? By making the variable equal to 1. If this is going to be some function of x, you just put x is equal to 1. 1 minus 2 plus 2 whole to the power of. Find the coefficient of x to the power 7 in the expansion of 1 minus x plus 2x cube whole to the power 10. This is the question. TR plus 1 is equal to 10CR into 1 power 10 minus R into 2x cube minus x whole to the 10CR. 1 to the power 10 minus R is okay. X to the power R into 2x square minus 1 to the power R. Suppose you put R is equal to 0. Then would you get a coefficient of x power 7 here? No. When R is equal to 1, what is the total power of, maximum power of x here? 3 only. And if I put R is equal to 2, what is the maximum power here? 6. There also I am not going to get. Right? So for 0, 1, 2 I am not going to get. Agree with me? Now, is there any better way of combining? There could be a better way. You see what happens. R is equal to 4, R is equal to 3, R is equal to 4, R is equal to 5, etc. up to R is equal to 7. Right? So you will be getting, you have to club so many terms. So is there any better way of arranging? That's what you have to think. Is there any better way of combining? So instead of writing the general term like this, you see how it would be if I write like this. 10CR 1 minus x to the power 10 minus R into 2x cube power R. Yes. Suppose R is equal to 0. Right? What I am going to get? 1 minus x to the power 10 into 1. 10C 0. When R is equal to 1, I am going to get 10C1 1 minus x to the power 9 into 2x cube. R is equal to 2. 10C2 1 minus x to the power 8 into 2x cube square. Every term is multiplied by x power 9. So naturally there is no coefficient of x to the power 7 in further to this. So you just have to club 3 terms only. You just have to collect 3 terms only. Are you following my point? I am going this way because you have already done. What is the answer?
116.
No, 164 is not correct. 960 is correct answer. Same method used is of course very simple. You just do it correctly, collect it correctly. In the first, You see, this is 1, this is 2, this is 3. In the 1, what do you get? Minus 10C7 is what you will get? Plus. Then 10C1 into coefficient of x to the power of 6. 10C1 into 2 into 9C6. Then 10C2 minus 10C2 into 2 square into 8C7. That's of course value is 8C1.
Sir, middle term లో 9C5 రావాలి సార్.
Yeah, 9C, because that is x cube, yes, 9C4 or 9C5, both are same, that is correct. So this is to be calculated and then together it should be 960. Okay. Now tell me what is the coefficient of x to the power of k. Coefficient of x to the power of k. In the expansion of 1 plus x plus 1 plus x whole square plus 1 plus x whole cube up to 1 plus x whole to the power n. What is the answer for the first question? What happened? This is again a GP. 1 plus x whole to the power n plus 1 minus 1 by 1 plus x minus 1, that is this. So 1 plus x whole to the power n plus 1 minus 1 divided by x. So what is the coefficient of x to the power of k? Is that correct?
Yes, sir.
Just check. So what is the answer?
N+1 C K plus 1.
N plus 1 C K plus 1 is the answer. Correct.